My background is in both architecture and engineering. I've been with Goettsch Partners for 20 years, and Jim Goettsch oftentimes will reflect upon us about what our goal is in designing the facades for our clients. And he really strives for elegant facades. And I don't want to do an imitation because there's a good chance he's in the room. But he'll often explain the analogy that a building facade is like a well-tailored suit. However, all it takes is a thread out of place, and that will be a distraction from the facade's design. So we work very hard at Goettsch Partners to make sure that we have no threads out of place on our facades. Today's lecture is going to focus on metal cladding systems for our tall buildings. Obviously, tall buildings have glass, stone, other materials. Today's focus, my focus, is just going to be on metal cladding systems. And for the group, I want to remind you of a times past. Tall buildings before the 20th century found themselves in very similar environments. We find CN Tower in Canada, Willis in Chicago, along with a number of other tall buildings in Chicago. The World Trade Center in New York. Even Petronas finds themselves in similar environmental conditions. But today, architects are being asked to design facades not in these environments. We're being asked to design facades in areas like the Middle East, developing nations like India, and specifically where we are today in China. And so the big message to the group is that we can't use the metals necessarily for the facades that we did prior to 2000 for these buildings in the future. They're in a different environment, and different considerations need to come into consideration. So today, if you look, I know there's another panel that's going to discuss what is the world's tallest building. This is one of the groups, 9 tallest buildings. And what's interesting is if you take the 9 tallest buildings as opposed to what we saw before 2000, what you'll notice is that the top 2 buildings find themselves in this Middle East environment. And then 5 of the 9, find themselves in China. So you might say, well, Pat, what's so interesting about that? What's so different about these environments? So what's different about these environments, again, big picture for the group is, and Jorn spoke about it briefly, I'll try not to overlap too much with him, is in the Middle East, we have conditions where we have a desert environment, heavy salt, but we have no rain. In our China cities, we have a higher pollution level than you're going to find, let's say, in New York or Chicago, Canada, Paris. So what we all have to consider, and we're preparing our facades for these tall buildings, is selecting the correct metal, the correct finish for these environments, because it's not what it was before 2000. So briefly, the presentation, I'm going to be talking about different metal enclosures. And for the group, I want to apologize. We're going to go through a lot of enclosures, and not all of them are going to be on tall buildings, and we'll discuss why. But unlike Jorn's discussion, which was purely on stainless, my goal is to find out what other metals are out there and how we can use them. In addition, we're going to talk about the factors for metal cladding. And then these are 2 parts. We're going to go through the pollutants, the salts, rains, and sand. Sand's a critical one, and I don't have a specific slide about it, but we have to understand in a sandy environment through weather storms that the finishes of these metals can be removed. And in the process of doing that, it can take away our corrosion resistance. And so it's very, very important. At the tail end, I'll talk about various detailing, galvanic action, some cost discussions. So I do like to try to keep the lectures interactive. So I have not seen any of the other speakers do this, but for the group, could you tell me what metal facades you're most familiar with doing, or what metals do we use in our facades? You can yell it out. What? Gold. Gold is one. I'm not talking about that one. Oh, he's a heckler. Okay, anyone else? Aluminum, very popular. Yorn. Stainless. What else? Titanium. Very good. We'll talk about that. Anything else? Come on, you guys. No one knows different metals to use? Copper. Excellent. Zinc is another good one. Okay. So we'll go through. Aluminum. Carbon steel. No one said weathered steel. Core 10 steel. Someone might have, but I didn't hear it. We talk about stainless steel. We'll talk about copper, bronze, similar to copper, and zinc. So again, my apologies. Many of the projects, and lastly, titanium. Many of the projects that I'm showing you, they're not tall buildings. But I think the group needs to consider these are the metals. These are what other than gold, these are the metals that we're typically using on our facades. And we'll talk about why some of these may be in the discussion, why some of these aren't being used on tall buildings. So the first metal is aluminum. And I think it's very important, I think everyone understands, that aluminum has to be coated. You can't take raw aluminum and put it outside. Well, you can, but it's just going to discolor. And so there's a variety of coatings that protect aluminum. And it gets very complicated, let me tell you. But let me simplify it for you. There are basically two types of coatings. There are liquid coatings, and there are powder coatings. And they come in a variety of different types. This particular project is Aqua in Chicago, a very nice high-rise. It consists of a PVDF-coated liquid coating that we use in the United States. Now, another type of coating, very popular in Europe, is the powder coats. The powder coats can also be in PVDF. People oftentimes think that PVDF, well, that means a liquid coating. No, PVDFs are used in powder coats as well as liquid coats. So why in Europe are we using powder coats? What's different about them? Powder coats are more environmentally friendly. They're on the cusp of being as corrosion resistant as liquid coatings, but they're just not quite there. So that's one of the differences. Now, the other coating, someone would say, well, Patrick forgot about anodizing. Technically, that's not a coating. It's a treatment of aluminum. It has limitations, not as many colors as we like to see in that we get in the PVDF, in the liquid and powder coatings. But one important consideration, it's basically an electrochromic surface treatment. So it's only on the surface. So we talked earlier about sandstorms. You think, well, then the anodizing is inherent to the metals. It's still a surface treatment. Unlike stainless steel, it isn't inherent throughout the whole material. That's a very important thing to remember when we're looking at selecting this material. Now, the very important thing is, I'm going to read a quote. This is a quote from the CTBUH 2009 Best Tall Buildings. The golden metallic mesh at the European Communities, the Court of Justice of the European Communities, the mesh is made of an anodized aluminum so that there is no risk of corrosion. And that's true, as long as the building stays in Luxembourg. Anodized aluminum is not necessarily the best coatings for heavy polluted areas, heavy salt areas without rain. So again, for the group, I think you guys are getting the theme. It depends on where your building is to determine what metals we should use to clad our structures. Now, someone would say, well, what do we do in China? Hotel Kapuk in Shenzhen, we use aluminum. Do we use a powder coat, or do we use a liquid coat? Typically, we use a liquid coat, PVDF, because it's the best corrosion resistance. And in an environment like China, this is a metal screen that clads the outside of the building. It was very important to maintain that appearance. We don't want any loose threads on some discoloration, some distraction to the facade. So the best PVDF coating that we felt was through a liquid coat. And that's primarily what you do in China. China has less restrictions as far as environmental restrictions. Powder coats end up using no solvents. I mean, that's basically what it is. So they have no VOCs. That's the reason why they're used throughout in Europe. So what are some other types of structures? Steel. Steel's great. It's strong. It's fairly heavy. And that's a limitation, especially for our tall buildings, putting on excessive things. It's very important that it has to be surface prepped and also coated. So very complicated, all the different coatings. There's two types. There's urethane and there's acrylic. Basically solvent-based and water-based. The acrylic, the polyurethane, is probably the best system out there. In addition, there's galvanizing and other treatments. But as far as finished appearance, what we're all looking for to adorn our facades, these are kind of the two. Weathered steel. That's a division of steel. A lot of people call it Core 10. Core 10 is like a name brand. It's the same thing. Weathered steel can't be finished, should not be finished. It needs to be left to the elements. But it's important to understand that it has to be in a wet-dry cycling environment. It should not be used in an environment that is constantly wetted. An example of it is the Aloha Stadium in Hawaii, where Core 10 Stadium was built in a constant, humid, wet environment led to corrosion. It's a misunderstanding. Core 10, weathered steel, continues to rust. And that's why it's critical that you understand how the water drains off of it, lest you stain everything on the details at the base of your buildings. We are still using Core 10 today. SOM has a project at the U.S. consulate in Guangzhou, and the base of the building use Core 10. So it's not a material that we're not still using. We'll talk later whether or not we'll see it on any of our highest floors. Stainless steel. I'll try not to duplicate too much of Jorn's discussion. Stainless steel, obviously great corrosion resistance, better for fire. Fire resistance better than normal steel. There are some cost ramifications, so we have some diagrams to talk about it. Basically, stainless steel costs more. The biggest thing that, not to mention, stainless steel can be coated to take on the appearance of other metals, gold metals, bronze metals, to give that appearance. This is the fish sculpture in Barcelona, completed in 1992 for the Olympics. So what's interesting, I listened to Jorn's talk about it. I think a lot of people, maybe here, I don't want to bore too much, but a lot of people think of stainless steel as stainless steel. And that is not true. There are ferritic stainless steels, 400 series, austenitic. That's typically what probably everyone in the room here is probably using the 300 series, 316. And then they have what's called duplexes, which are a combination of both the ferritics and the austenitics. To me, this gets kind of complicated. I really want the group to leave with basic understandings. We use 304 in normal, rural, suburban environments, low to moderate pollution. 316 we use when there's higher level of pollutants, moderate industry, and some coastal regions, as long as there's rain. Lastly, 2205. We use in desert environments, or potentially, as Jorn said, it needs to be considered in desert environments with severe salt. That's where I think the group, we all have to consider. So these are the basic, if you can remember that. 304, typical use, 316. So in addition to their corrosion differences, they also have different properties. So carbon steel, a stress strain diagram. I think most of us remember this from school. Might not remember. 300 series is slightly less strong in comparison. And what's interesting about it is 2205 is actually considerably stronger than both of these materials. And that's going to come in later when we talk about cost. 2205, we have the ability, it is, Loughran was kind of dancing around it. It's a raw material. Like anything, its pricing is speculative depending on the day, but depending on the market. But what I will say is 2205 can be thinner, and thinner can reduce the cost. So if we have a cost comparison of the different metals, 2205 by itself is the most expensive. But what's interesting is when you combine the typical buckling gauge reduction, many feel that it can become closer to 316 in cost, closer to 304 in cost. The big thing is we have to get the industry to provide us with finishes. Years ago, it wasn't possible to get all the finishes. You even said, Loughran, a lot of the finishes aren't available currently in 2205. But that's what this group's about. We have to start asking the question. So an example like even within the same environment, Blue Cross Blue Shield's headquarters in Chicago, we made the decision in the lower floors to use 316 stainless steels and then 304 up at the top. At the base of the building, that's where they throw the salts, the salt trucks. That's the environment that we wanted a higher grade. Visibly, you can't tell the difference between the two metals. So, copper. So copper, all of us are familiar with our copper gutters. Maybe not everyone has. It's something that has a patina. It changes with time. The alloy goes from dark and then eventually to green. Very limited corrosion resistance for salts. One important aspect, and we talked a little about it with the Core 10, the weathered steel, it's important when detailing copper to understand where the runoff is going. In some cases, it can very much be a contributing element to the design and detailing of the elements. Other times, you see it and it becomes kind of a distraction, like it wasn't really thought out. Like basically, it's just runoff. It's staining material. There's a project in Oak Park done by Nagel Hartray. I really love the museum. It's a beautiful copper facade brought out right at the beginning. And I thought, I live in the area, so I walked by it, and I noticed that, where's this pointer? I think you can all see it. There's this little dotted line across here. Students say that that's the dotted line that shows you there's something up above. I did call Nagel Hartray. They were very nice, and you know what they said. Yeah, we meant to do that. Anyway, the point is that we all have to consider how we're using these metals and where the runoff is, specifically for these. 60 Queens Victoria in 2000 used pre-patinaed bronze panels. So they actually come out with this green pattern from the start. And a friend of mine, my son has a friend that's studying abroad, and so just last weekend, I asked him to take some pictures, and the building looks pretty good. It looks different, but the aged bronze maintained its color. It didn't go to something else. I think this is very successful. Bronze, another project, American Art Museum. It's hard to find facades made of bronze today. Unfortunately, when I went to tell people to send pictures, this was a picture taken shortly after it was completed. I went to ask someone to take a picture of how it was weathering, how the group would like to see. Well, of course, they're tearing down the facade. The design of the facade, later in the discussion, we'll talk about sustainability. I think we all have to work with facades that the clients ultimately will take on for the life of more than 10 years. This project was completed in 2001, and they're already removing the facade for a different type of facade, a glass facade. Very unfortunate. So another bronze facade, originally in concept, is the National Museum of African American History in Washington, D.C. And I love the story of this. So they went through the design of this Corona screen, very important to the concept of the building envelope, and they got the pricing back. And would you know it? The facade cost more than the whole building. So they had to switch gears, and they went with an aluminum cast solution that then they painted to have the appearance of bronze. Now, I apologize, I passed over it. One of the reasons why people like anodized aluminum as opposed to the PVDF coating is it's a natural material. It's not a paint. And that's why a lot of architects are trying to strive for bronze, titanium. It has a natural material. It's just not painted metal. Anyway, I'm sure this will be enormously successful. Another project is the Jewish Museum. This is zinc. We've used zinc for our cladding structures in Paris for hundreds of years. It carries on a natural patina with rain. It oftentimes is combined with other materials like titanium. Zinc itself is fairly weak. And but what's very important when considering with zinc is the combination. Zinc is at the top of the anode, and for that reason has to be separated from other metals. The last one is titanium. What's interesting about titanium is its weight to strength ratio. And at first I thought, everyone thinks that's so strong. In truth, titanium finds itself all the way at the end. It's the strength to weight ratio. It's not that it's so strong, it's just so light. So here's a list of the varieties of metals used. Now, what do we have to consider? Pollution, number one, salts, rain, the lack of rain, and sand. So every city has a corrosion level. It's interesting, I came into Shanghai, flew in yesterday, and I noticed we saw big blue skies with clouds. But Shanghai has a variety of pollution levels throughout the year. This is taken from our office, depending on the levels. Shanghai, like other cities, can have high pollution, and so we have to consider that for the metals. At Blue Cross Blue Shield, stainless steel, 304 throughout, as we talked about, 16 down below. In China, our office typically uses 316 throughout the facade. This is a project, the Park Hyatt in Guangzhou. Now, these are so interesting. These are corrosion samples taken in Dubai. And look at the months. Look at 12 months of a metal, 316, without cleaning, to Jorn's part. Look at the discoloration. Now, prior to 2000, we were using our metal samples from a beach, Cure Beach in North Carolina. Well, they're both coastal, Pat. What's the difference? Well, North Carolina, it's raining. It's raining constantly. It's washing it out. Look at, very interesting, the 316 polished. The finish of the metal for crevice corrosion is so critical. Look at the polish compared to the 2B, which is a double finish. Very interesting. But the bigger picture is, look at 316. 12 months, the level of corrosion. That's something all these projects have to consider. Burj Khalifa, I talked to Peter Weissmantel before yesterday at the project, just kind of confirmed, they used 316. It was the product to use at the time. They used a polished 316. Very correct choice. Very smooth surface, less likely. But still, this building needs to be cleaned on a regular basis. So where are we going? Okay, so we have corrosion maps of a variety of different cities. Corrosion maps aren't only for salt, they're also for pollution. This is a map of Kuwait with a specific metal. Depending on what the metal is, depends on the corrosion maps. These are all available to the general public, developing nations. What's interesting about it, the metal, you can see this in common things. Look at here as an example of a commonplace object you find where they use 304 bolts versus 316 bolts. And then the base is 304 of this parking meter versus 316. This is through normal use. So these are some of the things that Jorn was talking about. If 316 isn't cleaned on a regular basis in these salting environments, it will have this discoloration. It's hard to call it corrosion. It's really, like Jim says, it's a distraction to the facade. So where are we going? So King Abdullah project in Saudi Arabia went away from 316. They went to 2205. And the goal is to have a material, you can tell by the actual structure of it, it's going to be a difficult building to clean. That has to be a consideration when selecting the metal, the finish, on a facade. So they went with the 2205, and we're looking forward to its completion. Here are some of the details of the close-ups. Again, they saved some cost it's a stronger material than the 316. So a couple tricks, galvanic action, a couple more subjects. I gave this speech to some younger people in the office the other day, and they didn't like this analogy. But I always struggle here. I'm going to jump ahead. I always struggle with getting that galvanic chart right. So on the left, you see an example of what is done right. On the right, it's wrong. Okay, so basically you've got stainless steel fasteners that are on a carbon steel metal. And that is the right thing. Over here we have zinc fasteners that are on stainless steel. And so my analogy was, they didn't like it, let's focus on the spade. So what you want is, I'm going to go back one more, you want the smaller metal on the lower end of the chart, and then the larger metal. So in the first example, we had stainless steel on the bottom part, and then aluminum on the top. That's the right way. The wrong way is to have a zinc fastener, which is the smaller metal on the top, with the larger metal down below. So last example, a project in Bordeaux. The architect wanted, like we talked about for anodizing, they wanted the aluminum to have some depth. And so they went with anodized aluminum, and they put a lacquer finish on the raw aluminum. Now, I visited the project in 1999, and I noticed that there was this crevice corrosion, or it was like a leaching that was coming in at the edges of the panel. And what it is that they had prepared the panels, lacquered them, and then they cut them. So what did we have? We had an unfinished edge at the end. Pat, you're so picky. You know, you got to get up so close. Well, there's a certain disease. Actually, it's called film form corrosion. And these are the images that come up on the internet. And this is what the project looks like now. Okay? This is 14 years later. So that film form corrosion from that edge comes all the way through. They're plagued with the problem. What are they going to do? Go back with replacement panels. This is worse than a loose thread on a building. Okay, this is a big problem. And the solution really is selecting the right finish coating from the start. Very important. All of us have to consider crevice corrosion. We can't have details that can hide water, collect it in certain areas. We have as I love showing this video. It's very interesting. You know, Pei's project, I can't remember, 88 probably. The project was completed in Paris. And, you know, they really didn't have a way that they could clean the facade well. So in 2004, a company came in to show them how they would do it. And they developed this robotic man thing to go through. And it's critical for the Louvre that the light goes through. And anyway, it's very interesting. So now it gets partners whenever we come up with a very intricate, complicated design, and someone says, well, how are you going to clean that? Robots. That's what we say. Okay, well, today's lecture was focusing on how to design our metal enclosure system. My goal would be to hope that all of you can design facades without any loose threads in the future. Thank you very much.